This experiment is lagged pipe apparatus. So in this experiment we are going to determine the thermal conductivity of the asbestos and the sawdust. So at the interior surface you will be provided with an heater surrounded by asbestos. After that you will be having a sawdust. So this R1 is the heater radius, R2 is the outer radius of the asbestos, and R3 is the outer radius of the sawdust. So thermocouples are fixed at different places. For heater it is T1, T2, T3. For asbestos it is T4, T5 and T6. Outer surface of the sawdust it is T7 and T8. So the diameter of the heater is 20 mm. D2, so that is heater with asbestos diameter is 40 mm. Then D3, which is asbestos and sawdust including outer diameter, which outer diameter is 80 mm. So length is 500 mm here. So these are the specifications. Initially, now I am going to increase the voltage, so set to 100 volts. Set to 100 volts, and you can measure the value of current. So you have to wait for 10 to 15 minutes for steady state values. So after that you have to take the readings from T1 to T7. So T1, T2 and T3. So these three values are the heater temperature. Then asbestos outer temperature, which are represented by T4, T5 and T6. So T4, T5 and T6. So these three temperature are asbestos temperature, and T7, T8 are the sawdust outer temperature. Since after steady state, if you take readings means it will get higher values. Okay. So this is first set of reading. Our next set of reading can increase the voltage to 120 volts. So again you have to wait for 10 to 15 minutes for steady state, measure the value of current and take the values from T1 to T8 and mark it in the table. This is tabular column for lagged pipe apparatus. So they have set the values of voltage to 55 and they have measured the current to be 0.3. So after 10 to 15 minutes, if you measure the values of T1, T2 and T3, so average temperature you have to measure. So then asbestos temperature, which are represented by T4, T5 and T6. From the readings you have to note here. So these values, and you can take the average of T4, T5, T6, that is your average temperature. So next sawdust temperature is T7 and T8. So that can be noted from the thermocouple values. So that average temperature you have to measure here. So average temperature of the heater, which is T1 plus T2 plus T3 divided by 3. So you will get one value. So here we are having four values, so that we are having four values here. So next average temperature of asbestos lagging is T4 plus T5 plus T6 divided by 3. So that is the average value. So next average temperature of sawdust lagging, which is T7 plus T8 divided by 2. So these are the average values. So next for determining the thermal conductivity, the formula is Q equal to K1 into 2 pi L into del T divided by ln R2 divided by R1, which we have seen already in the hollow cylinder in class itself. Thermal conductivity for hollow cylinder, this formula is also available in data book, page number 62. So K1, which represents the thermal conductivity of asbestos, this is constant value which is 0.1105 watt per meter Kelvin. So R2, which is the radius of asbestos lagging with 20 mm, R1 is the radius of heater 10 mm, L is the length of the heater, which is 0.5 meters, R3 is the radius of sawdust, which is 40 mm. So these are the specifications. Q is the average value. So we have four readings, so four set of values have been noted here. So then determining the thermal conductivity of sawdust, so same formula can be repeated. Q equal to K2 into 2 pi L into del T divided by ln R2 by R3. Instead of that, you can replace by R3 divided by R2 for determining the thermal conductivity of sawdust. So if you put the value of Q here, except K2, remaining all values are known. So if you solve this, you will get the thermal conductivity of the sawdust. So thus the aim of the experiment is completed, which is thermal conductivity of the sawdust and asbestos materials have been determined.